Audio Jungle. Audio Jungle.
Right, so here we have a variation of shear force, variation of shear force and bending moments So we have table. The table is nothing but types of load. We'll talk here SFD, BMD, between point load, or for no load region, or for no load region. Then we have uniformly distributed load, which is also called UDL. Then we have uniformly varying load. Uniformly varying load, which is also called UVL. Right, now coming to this, see what about to SFD, shear force diagram. SFD, what about to SFD, that is shear force diagram. If between point load, or if there is no load, then what will be the curve? The curve will be horizontal line. For SFD, I am saying horizontal line. And if there is a uniformly distributed load, then SFD curve will be inclined line. Okay. And if it is uniformly varying load is there, then SFD will be 2 degree curve, that is parabola. I'll write here. Then we'll talk about bending moment diagram, BMD. Bending moment diagram. 2 degree curve means parabola. Okay. Then we'll talk about BMD. So if bending moment diagram you are going to draw, and for what bending moment diagram you are going to draw between any point load, or if there is no load also, then you have to draw inclined line. Inclined line. And if uniformly distributed load will be there, then 2 degree curve. Okay. If it is uniformly varying load, then 3 degree. Okay. If I say 2 degree curve, that meaning itself is the parabola. Parabola. Okay. It's parabola. And 3 degree curve is there, then it's a cubic parabola, or cubic parabola. Right. You need to remember. So this table you need to remember, and based on this table we have to draw the SFD and BMD diagram. Okay, it's very simple actually. So while you are drawing the SFD and BMD, this table you need to remember. That's all. Nothing is required, because in this chapter basically numerical will be asked to you, and frequent numerical will be asked to you. So this is the one important table, and you have to use the technique, then you will able to draw. Very simple. Right. Now coming to the numerical part here, we'll draw SFD and BMD. This is the first problem. So you just focus here, then it will be easy for you. Okay. Problem. What is the problem here? The problem is draw shear force diagram. Shear force diagram means SFD and BMD and bending moment diagram, which is called BMD. Okay. Or simply supported beam. For simply supported beam subjected to 3 points loads as shown in figure. Okay. Now, so we have to draw for simply supported beam. So this is the beam. Beam is nothing but horizontal structural member. This is the beam. This is the beam now. This beam is what simply supported. So this beam is what simply supported. We can say simply support is something like this. This is its simply supported beam. This beam is simply supported beam. For simply supported, always remember one is the fix, another is roller support. Okay, so now this becomes simply supported. This is the beam here. This horizontal structural member always called as a beam. Vertical structural member always called as a column. That you need to remember. Now we have, they said, three points loads. The beam is subjected to 3 points load. So 3 points load. First point load is nothing but it's 5 Newton. Another is 10 Newton. Then this is nothing but 8 Newton. Distance of each loads from the support is given how much? 2 meter. This is also 2 meter. This is 3 meter, and this is 2 meter. Okay, this is the, sorry, this is 1 meter. I'm sorry. This is nothing but 1 meter. Okay, this is nothing but 1 meter. So distance of the each loads they have given. Okay, fine. So to start SFD and BMD, we should aware with the all loads. So now you can understand, because this is the beam. So obviously here this is the support. Okay, so we will have a reaction force here. Okay, we can give the naming of this beam. Just say end A. This end is A and this end is B. So what will be the reaction force here? It is RA. And what will be the reaction force here? RB. Because we have support. Okay, we have support. This is the support. So support always give the reaction forces to the beam. Then only it is stable. Like we are standing on the surface of Earth. So why we are standing? Because Earth is giving the reaction force to us. And what will be the reaction? The weight, our weight, the same. Uh, what is the weight? Our weight, the same force. It is giving the reaction as a reaction force. So because of that only we are able to stand on the surface. You got my point. So right, so because of the support we can understand we will have a reaction force. Because of that only that beam is what is stable, and it is simply stay at that position, because if there is no reaction then beam will not be able to stay at that position, right? So we have reaction. So whenever you will get support you will have a reaction force there. Okay, now coming to the first step. First step, always remember we have to, I'll write all steps so it will be easy for you. What is the step one? Step one is what? Finding reaction force. Finding reaction forces, that is Ra and Rb. So first we should know how to get the reaction force Ra and Rb. So I'll draw the beam again. This is the beam now, and simply I can say this is Ra and this is what? Rb. We can randomly, its measurement is not important at all. What is the exact distance? Only the distance you have to write this. Random you can draw. This is 2 meter. Then again we have at 2 meter again we have a 10 Newton. Again we have a 3 meter. One more load we have. This load is nothing but 8 Newton. And obviously this distance is nothing but 1 meter. All right, the same beam I have taken once again. Now how to get the reaction? Just listen carefully. We have to take moment about any point. Generally we'll take about the moment, uh, any point you can take, because 2 points you have, A and B both we have. So I'm going to take moment about A. Okay, so first step, this is the step one. So we have to write taking moment about A. So we can say this is MA, and this is the moment balancing. So if you take moment about A, so summation of all moment clockwise anti-clockwise moment you have to take algebraic sum and make it equal to 0. That is the moment balancing. So we are taking moment A, so you can write summation of MA is equal to 0. That's the mean of it. So because we are taking moment at point A, so because of this RA will not get any moment, because we are calculating moment at point A. This is point A and this is point B. So but because of 5 Newton will get moment at point A, because we have perpendicular distance 2 meter. Because of 10 Newton force we can get moment at point A. We have 4 meter distance. Because of 8 Newton we can get moment about A, because we have distance of 7 meter. Okay, because of Rb also we can get moment at point A, but because of Ra will not get moment at point A, because we do not have any perpendicular distance. What is the moment? Moment is nothing but force into perpendicular distance. So we are finding moment at point A. So because of Ra will not get any moment. That is one. Second thing, if you check 5 Newton, so about point A, this 5 Newton will have a clockwise moment. Okay, because of the 5 Newton about this point A, we will have a clockwise moment. If you how you would know it is clockwise or anti-clockwise? See the force. So force is what going downwards. So we'll follow the intense of the force. So natural direction for this load is what? Downward. So I will take the rotation as the direction of the force we have. So this rotation about point, because we are taking moment about A, so we make the one rotation about point A because of 5 Newton. So 5 Newton, because it is going downward, so this rotation will be something like this about point A. So now you can say, okay, about point A we have a clockwise moment. Similarly, this 10 Newton also, if you see, then again it will give the clockwise moment. So this is also clockwise. What about RB? RB, it is going, load is going upward direction. So again, you have to draw the rotation about point A, and this rotation, because force is what going upward, so this rotation will be anti-clockwise. So because of RB you will get anti-clockwise, because of 8 Newton you will get clockwise moment here, because of 5 Newton you will get clockwise moment. So you have to check the direction of force. This is very simple idea, because here always remember we have to focus on the, once you are going to calculate reaction, the moment you have to calculate, even though bending moment also if you are going to calculate, you have to take the, you have to check the rotation, it is clockwise or anti-clockwise. So generally we are following clockwise moment is the clockwise moment is the positive and anti-clockwise moment is the negative. So this 5 Newton about point A will give the clockwise moment. If I write the equation, then it will be 5 into, from point A, what is the distance? 2 meter, and this is clockwise moment, hence plus. Similarly 10, this is clockwise moment, so it is 10 plus 10 plus 10 into what is the perpendicular distance from point A, it is 4 meter. So this, similarly 8 Newton also will give the clockwise moment, hence it is plus, into perpendicular distances from point A to 3, means 4 plus 3 7 meter, right? Now RB, if you check it, it will give anti-clockwise moment, hence it is negative. RB into what is the, for RB what is the RA distance, or what is the distance for RB from point A? So it is 2 plus 2 4, 4 plus 3 7, 7 plus 1 it is 8, and equal to 0. Now it's very easy, 5 10 plus 40 plus, and this minus you can take RB into 8, right? If you see, this is nothing but 100 is equal to 8 RB, right? Now what will be the RB here? It's 100 by 8. It's nearby 13.25 Newton. Now see RB you are getting positive, means whatever the direction of the reaction force you have assumed here RB, it is correct only. So, and correct in the sense you have assumed upward direction RB, so this RB is what upward only. Suppose you have taken RB direction upward, but RB value you are getting negative, so it means that you have to show the actual direction of RB will be negative. But here RA and RB reaction force you have assumed in upward direction, and RB value you are getting positive, means whatever direction you have assumed, that is correct one. Now once RB you got here, so what is the next step? Again you have to calculate RA also, because your job to calculate first RA and RB. So RB just now here you have calculated what is the another equilibrium equation. This is the first equilibrium equation you have used. So you got the RB. Now another equilibrium equation you can write summation of all the forces. Okay. So you can write using the condition, using the condition. What is the condition? Summation of all the forces in vertical direction in y direction is equal to 0. This is the equilibrium equation. Three equilibrium equation generally we have summation of fx means horizontal force is equal to 0, summation of fy means all the vertical force equal to 0, and taking moment about at any point equal to 0. Three equilibrium equation we have. The first equilibrium equation we have used here, because we are interested in RA, RB, which is nothing but vertical forces. So the second equilibrium equation we can write summation of Fy. So summation I am writing, then it means algebraic sum, plus minus all the force. If it is upward, then plus. If it is downward, then take negative. Like I'll show here. RA is what? Upward. So all upward forces you can take positive. RB here it is upward, so take RA plus RB. And see 5 Newton is what? Downward. So downward forces you are taking negative. 10 Newton is what? Downward. So downward forces you are taking negative. 8 Newton is what? Downward. So you are taking negative, and this is equal to 0. That's the mean of the summation of Fy is equal to 0. Now you see Ra plus Rb is equal to, this is 10 plus 5 plus 8. What is the value? It is 23 minus 23, but if you take equal to, then it will be 23, right? So you can say this is the one equation, and if you say RB value you have now, just now you have calculated 13.25. So RA plus 13.25 is equal to 23. So what is the RA? It's nothing but 23 minus 13.25. If you calculate nearby, 9.75 Newton, I think you will get. See, RA is also you are getting positive. Hence, whatever the direction you have assumed correct, what direction you have taken, it is upward. So means it is upward direction. So now both value you have calculated. That was your first target. That was first step RA and RB. Just now you have calculated. This is the first achievement actually. This is the first achievement, which is nothing but 13.25. Because without knowing the forces, you will not able to draw SFD and BMD. Okay, so if any force is what are known, you will not able to draw SFD and BMD. So first you should just find out the forces, because reaction is what, it's a forces only. So okay, RA and RB is now aware. You are aware with this value. Now you can go for the SFD and BMD. So again, once you got this unknown forces RA and RB, now you draw your complete beam, because this beam is what completed, but here RA and RB was unknown. Now it is known. So again you have to draw beam. Okay, again you have to draw beam and just give heading step 2. Step 2, you are going to perform calculation of SFD. Okay, not SFD, calculation of shear force, better, because SFD means shear force diagram. So first you calculate all the shear forces, then only you will able to draw, right? So calculation of shear force you have to write. Calculation of shear force. Calculation of shear force. Right? This is the step 2. So if once you are going to calculate shear force, so again you have to draw the beam with all the forces. So this beam, if you see, all the forces means RA. Just now you have seen RA, you have calculated how much it is, 9.75. Okay, and RB you have calculated 13.25, right? We see the all loads, nothing but 5, 10, 8. 5, 10, 8. So this is 5 Newton, 10 Newton and 8 Newton. And always make practice to write distance 2 meter. This is 2 meter, 3 meter, it's 1 meter. Although for the shear force calculation, this distance is not required at all, but still we need to write, because we have to calculate the moment. Okay, moment calculation, during moment calculation, this distance is what required. Always remember. Now, to start this calculation of shear force, you always make this practice. This is the trick I'm just going to tell you. You always follow, and if you follow this, then definitely you will be able to solve the problem without any problem, without any confusion. You will be able to crack. Okay, this is the force one. So whenever any force you are getting, you just make a bracket like this. Okay, give the naming. Just say this is 0, 0. This is 1, 1, like that. This is the again force. So you just put in bracket. After 1, 1, this is what, 2, 2. This is 3, 3. This is again one more force. So this is 4, 4. This is 5, 5. This is 6, 6, 7, 7. And this is also force, no? Reaction force. 8, 8, 8, 8, and 9. 10. Why we are making a bracket here? You just understood easily. You will understand. We have to write the force. See, in few books it is given left and right. What is this 0, 0? It is the it is the point, you can say. It is left to the force. 1, 1 will be right to the RA. and 0 0 is left to the RA. Similarly, 2 2 is left to the phi, and 3 3 is the right to the phi. So, and also 2 2 is the right to the RA. See, where is 2 2? It is the right side to the RA, right? Where is the 0 0? It is left side to the RA. See, this is the RA. So this side is what? Left, and this side is what? Right. If I say 0.11, so you have to say it is right to the RA. And what about this 2 2? So you just make a point. This is the one middle line for 5 Newton. So this side it is left to the 5 Newton, and this side it is right to the 5 Newton, because left to the 5 Newton is 0.22. At the same time, for RA, 0.22 is the right side. Right side for RA. For RA, basically 1 1 is right side, as well as 2 2 also right side. For 5 Newton, 3 3 is right side, but 2 2 is left side. Okay, this type of sign convention, if you, I mean, the pointing, if you give, no, then it will be very easy for you. Okay, so means you are just going to check just ahead and behind what is the value of force at any point. See, I say this is the point A and this is the point B. In the beam, you have given the name A and B. We have to calculate each and every point. We have to calculate the forces. So we are interested about this 10 Newton. We should know just behind what is the forces for 10 Newton, and what is the just ahead to 10 Newton, what is the forces, what is the value of the forces, that we have to check. Now, okay, I will solve, then you will understand. We are going to first write V00 or F00, because we are writing for the shear force. So shear force calculation we are taking, suppose F. This is the shear force calculation. So if I'm saying F00, it means left. We also can say RA left side. RA, the force, reaction force, and what is the LS? LS means left side value. That also we can write by the F00. The meaning will be same. And what is the value here? Left side to the RA, there is nothing, no value, so you just make 0. But at the same time, F11, shear force F11 means we are just right to the RA, so we can RA right side. Okay, so just right to the RA, what is the load? Because if you reach just right, means you are reaching at 0.11, then right side, what will be the force? RA will be the force. F11 means you are just right to the RA. So just right to the RA means you are moving in this direction. So earlier you were at 0 0. So definitely, because 0 0 is what? It is just before the beam started. So obviously there will not be load. But what is the 1 1? It is just after the beam started. So once beam started, then what is the reaction force? It is RA, and it is in upward direction. So RA will be plus, F11 will be, it will be plus 9.7 Newton. Now if I reach to F22, just listen carefully, you will understand. F22. Okay, so I'm not going to write left and right, only I will write this value F22. F22 means you are reached at this point. Okay, so if you see it, once you reach at this point 22, so what is the total load behind this 22? So behind means this side you have to watch, and if you see this side, then you will get only 9.75. Only 9.75 Newton we have. That's the reason I told you F22 is just left to the 5 Newton or right to the RA, but meaning will be same. So what is the load available? Only 9.75. Okay, but at the same time, if I say what is the F33, so F33 you see means you reached at this point, means you cross the 5 Newton, and after crossing 5 Newton you will reach at 0.33. Now you will see how many loads are there, RA and 5 Newton. RA is what going upward, so it is plus 9.75 because it is upward. And if you see 5 Newton is what going downside, so it is 5 Newton. Now if you check what is the value, it is 4.75 Newton. So F33 is nothing but 4.75. Now coming to the Next calculation, which is this part is done. Now you reach to F44. So F44 means you are standing here and you are looking this side. So how many loads are there? Ra 5 Newton. Okay. So Ra is what, as I have shown you, Ra is what upward, so 9.75, and 5 Newton is what downwards, so it is 5. How much you got? 4.75 Newton. Now what is the F55? F55 means you just reach at this point, and if you are standing this side, if you see the loads, how many loads are there? So 9.75, 5 Newton, and this 10 Newton. This 10 Newton is what going downward. This Ra is what 9.75, because in upward direction 9.75. 5 Newton is what going downwards, so it's a negative, and 10 Newton also going downwards, it's a negative. So how much it is? 9.75 minus 15. 9.75 minus 15. So if you calculate this value, so you will, this value you will get minus 5.25. Okay. What is the F66? So for the F66, obviously the same load you will get like 9.75 upward, 5 Newton downward, and 10 Newton downward. So same value you will get 9.75, because it is upward, so plus 5 Newton is downward, so negative, 10 Newton is downward, so negative. If you calculate, minus of 5.25 Newton. Now if you check the next load, which is nothing but F77. So once you reach at 77, so again if you see the loads, 9.75 upward, 5 Newton downward, 10 Newton downward. Then one more load, which is 8 Newton. Now you got, it is downward. At once you are at 0.77, so 8 Newton also will be considered. Now it is what? 9.75 minus 5 minus 10 minus 8. Now, so what is this value? This value is basically, see, 10 plus 5, 15, 8, 23, 23 minus minus 23 plus 9.75. So if you solve this, then approximate, well, not approximate, exact value, we will get 13.25 in minus. This is 77. Again, if you say 8, this value will be the same, minus 13.25. But if you reach to point F99, so see, all the forces will be minus 13.25. Here you have calculated, but once you are at 0.99, then again RB will also be added, and RB is what? In upward direction. So you make it plus. So what is the F99? So F99 is nothing but you got minus 13.25, and once you are at 0.9, then RB will be added. Once you are at 0.88, then RB will not be added. For that reason, 88 directly I have written 13.25 minus. But F99, if you check, then RB will be added, which is in upward direction. It's minus 13.25 plus RB. Now what is the RB value? 13.25. Now this is 13.25. You will get 0. So this is the cross check also always when once you calculate the value. So just before beam started, your force will be 0. Just before beam started means I'm talking about this value. See, just before beam started, what is the 0, 0? Just before beam started, because from where beam is started at point A. But 0, 0 is what? Just before A. So just before A, obviously, just before the beam. So just before the beam, force will be 0. That is 1. And what is the 99? Just after the beam. Up to what point beam is there? Up to point B only beam is there. What is the 99? It is just after the beam. So just after the beam, always forces will be 0. So for that reason, you are getting F99 is equal to 0. This point this is point once you remember for the cross check. Okay, always I'm saying. And other conclusion, what I just want to tell you, see, so always you will be free. See, 2-3 numerical ones you solve, then you will be master of this. It's very easy actually. So 1-1 means what? It is just after RA, but if you check 1-1 and 2-2, it is same. Why? Because in 1 and 2 in between there is no force. So what will be the 1 1 value? Same value will be 2 2, because in between there is no force. So that's the reason 1 1 and 2 2 both are, you are getting same. Similarly, F3 3 and F4 4 both are the same. Both are the same. In between there is no forces. So see F3 3 and F4 4. Okay. At the same time, if you check the next force, which is F5 5 and F6 6, both are same. So F5 5 and F6 are same. F7 7 and F8 8, because in between there is no force, it will be same. It is same. But if you check 0 0 and 1 1, both will not be same. Why? Because in between there is the force Ra. For that reason 0 0 and 1 1 are not same. 2 2 and 3 3 will not be same. Why? Because in between there is the force. What is the force? 5 Newton. So see, 2 2 and 3 3 both are not same. So these are the techniques. That's the reason I told you, if this method or this technique if you follow, then your answer will be 100% accurate answer you will get. There will not be any chance to make any mistake. Okay, done. So all the forces you have calculated. Once forces you have calculated, then you will able to draw the shear force diagram. What was step 2? Calculation of shear force. Now step 3 will be step 3. So shear force diagram, now you are going to drawing. For SFD you are going to draw. So how to draw? It's very simple. Always make a practice. Once you are going to draw SFD or BMD, so again you have to draw the beam. So why you are again and again why you are drawing? Because you will get the correct an easy calculation. I mean, calculation you already have done, but the accurate you will able to draw, and without any mistake. Otherwise every time you have to draw the turn the pages, in examination. So better each pages, whenever you are going to draw or whenever you are going to calculate, every time you just draw the beam. That will be better practice. So this is nothing but Ra, and Ra you just now you have calculated, it was 9.75 Newton, and then you have calculated this value, which is nothing but 5 Newton. It is 2 meter away from this point. This is point A. Okay, and then again at 2 meter distance, again you have one more force, which is nothing but 10 Newton. Then again at 3 meter distance, you have another force, which is nothing but 8 Newton. And then this is what, 1 meter distance, and this point is what, B. And just now you have calculated Ra and Rb. So Rb was 13.25 Newton. All right. Now, so if you have drawn again beam and you are going to draw SFD shear force diagram, so all the points you have to extend downside. All points. Okay. Where are the forces acting? All the points you have to extend downside. Something like this. Something like this. Right. Once you have drawn all the forces and you extended downside, so again now you will take one reference line. If this reference line is required, because sometimes you see the forces you are getting positive, sometimes see here you are getting positive, but sometimes you are getting negative also. Yes or no? So to draw all the forces, we should have one reference line. And why reference line? Because upward side if you draw, it will be positive, and draw downside it will be negative. That's the mean of it. That is the reference. And make practice this, make as a 0 0. So upward side will be all positive forces and downside will be all negative forces. Now coming to the first point A. So at point A, check any force is there. Yes, what is the force? 9.75, and it's a point load. Once point load will be there, only you will get a straight line. Okay, in SFD. So you will able to draw. See how you would know this. For that reason, I have given the table. See, this is the now table is important here. See, just now we had seen table here. So SFD you are going to draw. First you are focusing on a shear force diagram. So between point load or no load region, two things you need to remember. between point load or no load region, okay, then what will be the line? That line will be horizontal line, okay. The line will be horizontal line when there is no load. But here if you check, we have a load at point Ra. So once you want to show the shear force, so at point Ra you have to draw the what, because Ra is in upward direction positive, 9.75 Newton is positive, so hence you are going to draw positive side, you have to draw one line, something like this. Okay, I should draw with another color like this. This, so this value approximate, scaling, it's not required every time, you just measure approximate, you can say like see 9.75, so it will be the more than 5 Newton, so obviously 9.75 line will be more than 5 Newton line. In that way you can draw the compare, and you can draw it. So this line I am drawing just approximate for 9.75, so I can say this value is now 9.75. This is point A. Now if you reach for the 5 Newton, so just before the 5 Newton, just before, now you can give the naming also A, B, so you can say this is what C, this is what D, and this is what E. It's your choice, if you want to give, you can give. Now just before the 5 Newton, just before the 5 Newton means, I told you just before 5 Newton means 0.22. Check, okay, you have drawn for AA. Just before AA it was 0, so for that reason just before AA it was 0, 0 0 line, so 0 0 line force was 0, hence you have started from here. Just before AA, what was the force? It was 0, for that reason this line started from 0. Just after AA, what is the force? 9.75, so you just reached here. Similarly, just before 5 Newton, just before 5 Newton, just before 5 Newton means it's 0.22. What is the 0.22? 9.75. So the same force you have to take, and if you see in between A and C, there is no load. A and C, there is no load, then what will be the line? What will be the line? Horizontal line. How you would know? You see the table. For that reason, table has been given. Between point load, for no load reason, if there is no load, then SFD you will have to draw horizontal line. Okay, between point load. What is the point load? See, this is the point load. I have shown you this point A RA reaction force, which is nothing but 9.75 and 5 Newton. This is the point load. And in between point load, if there is no load, C, A and C in between, is there any load? There is no load. So you have to draw horizontal line. So you have drawn. It is just before 5 Newton, means just before 5 Newton means it is 2 2. And just after 5 Newton means it will be 3 3. So just after 5 Newton means 3 3. So 3 3 will be 4.75. So 4.75, it is just after 5 Newton. So all the, because just before 5 Newton or just 5 Newton, just after 5 Newton, both are associated with 5 Newton. So always you have to draw the same line, means here only, because this value is what, 9.75 Newton, but just after 5 Newton it becomes F33. So just after means it will be the same point, but now it becomes just after C, means just after C means C, focus here, just after C means 3 3. What is the 3 3? It is 4.75. So earlier just before 5 Newton it was 2 2, means F22 was 9.75, but just after 5 Newton it becomes 4.75. So 9.75 is more than 47.5, or you can say 4.75 is less than 9.75. So you gone down because the value is what, decreased. So you reached here, you reached here, and now what is this value? This value is nothing but 4.75, right? Now see, so it is just after 5 Newton. Now see, just before 10 Newton. So just before 10 Newton means what? Just before 10 Newton means 4 4. Just after 5 Newton it was 3 3. Just before 10 Newton it is 4 4. I told you 3 3 and 4 4 will be same. See, 3 3 and 4 4 will be same. So just before 10 Newton we have to write for the 4 4. And in between 5 Newton and 10 Newton, is there any force? No force. If there is no force, then again you have to check the table. If there is no force between 2 points load, so what will be the line? The line will be horizontal line. So you have to draw the horizontal line again. Okay. So again, you have to draw the horizontal line between these two forces. So now this will be the horizon. Still, just before 10 Newton, what is the value? This value is nothing but 4.75 Newton, just before 10 Newton. Huh? Now, what is the value just after 10 Newton? Just after 10 Newton means, just after 10 Newton means what? It's a 5.5. So check 5.5 becomes minus 5.25. It becomes minus 5.25. So where you will get minus? Minus you will get downside. So you have to go downside. And now what is the value here? It is 5.25. You came downside, so no need to write minus again. If you write 5.25, so it will be considered as negative because downside it is negative. 5.25. It is what? Just after 10 Newton. Now check just before 8 Newton. So just after 10 Newton and just after 10 Newton and just before 8 Newton, there is no force. So it will be same. For that reason, just after 10 Newton means 5.5. Just before 8 Newton means 6.6. So 5.5 and 6.6 both are same. So, and in between, obviously there is no forces. So you can draw the horizontal line again. So again, the horizontal line you have to draw. And this value is very clear. It is 5.25. Now you reached just before 8 Newton. You see what is the value just after 8 Newton. So just after 8 Newton means, just after 8 Newton means it's a 7.7. What is the 7.7? It becomes minus 13.25, means more negative. Means more negative. So you have to go more down because more negative you got, and this is 13.5. So I can say, or more negative means here you reach and say this is the 13 point. I told you no need to write minus sign here because downside it means it is negative. So it's a more negative, so means you will go 13.25, which is very downside value. And this is after 8 Newton. See, after 8 Newton and before RB, after 8 Newton and before RB. Before RB means 8. So 7 and 8 I told you that time also it is same. So just after and before, if in between there is no force, then value will be same. So see, at 8 Newton and RB in between there is no force. So just after 8 Newton, which is 7 and just before RB it is 8. Between 7 and 8 there is no load. So value will be same. Hence it is 13.25. And if there is no load between 2 points, then the line will be horizontal line. So again, this line will be horizontal line. Something like you reached here. What is this value? 13.25. Okay. You have started your calculation at point A, that is the actual beam, and you have end up at point B. You are just before B. You have not reached B. It is just before B. What is the value after B? What is the value after B? See, after B means after RB. So what is the value after RB? After RB means 99. Yeah? So 99 means, see, the 99 value just now you have calculated, it should be 0. So again, because this is the 13.5, you have to meet with the 0 line because this is the 0 line now. So meaning is you have started your calculation from 0, that is before AA, that is before 0, that is before point A, which is 0, and you have to end up just after B, which is nothing but 99, and both value must be 0 because just before A, what is the force? 0. So you have started from 0. What is the force after B? It is 0. So again, you have to end up with 0. This is your shear force. Now, if you see, you also just for the good appearance, you can hash this. So this will be your shear force diagram, and it is well known because you made the reference line and above side it is plus. So no need to write, but sometimes if you are interested, you can write this side plus and this side minus. It's your choice. If you are interested, if you are not interested, no issue. This is called shear force diagram.